All right, everyone. Let's finish exponent rules today. So let's review what we did last time. So the thing that we did last time was number one, the exponent rule. When you have a same base, for example, I have a base A raised to the mth power times base A raised to the nth power, then you add the exponent m plus n. So for example, if you have 3 square, it must be multiplied. You have to have a same base and raised to the fifth power, then you actually do 3 second plus fifth, which become 3 to the seventh power. The reason is this. The reason is 3 square means 3 times 3. 3 to the fifth power means 3 times 3 times 3 times 3 times 3. And there's a multiplication right there. So multiply. So at the end, how many 3's are there? I have a 1, 1, 2, 3, 4, 5, 6, 7. So 3 to the seventh power. So in short sense, when you have, let me highlight, when you have a same base, you must have a same base. Then you simply add the exponent. All right, number two, pretty much the same thing, but when you have a same base, a to the nth power, now divide by a to the nth power, then you subtract. When you subtract the exponent, it is always top minus bottom. So for example, if you have a 4 to the 7th power divide by 4 to the 2nd power, then it is 4 to the 7 minus 2, then therefore it will be 4 to the 5th power. The reason is this. 4 to the 7th power means you have a 4 times 4 times 4, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay. Divide by 4 to the second means 4 times 4. And we can now cancel. So this one cancels out. This one cancels out. Same thing over same thing, that cancels out. So at the end, what do I have left is in numerator, I have a 1, 2, 1, 2, 3, 4, 5. So I have 4 to the fifth power over 1. Of course, we do not write that one, so it's just 4 to the fifth power. So in short sense, let me highlight. When you have a same base, you have to have a same base for the exponent rule. You are going to subtract the exponent 7 minus 2, but always top minus bottom. So let's write that. Exponent rule, let me write big, must have the same base. All right. The third one that we learn is coming from the number 2 actually. So if I have a to the nth power divided by a to the nth power, it become a 1. Well, you guys remember same thing over same thing is always cancels out, become a 1. But the reason is this. So for example, if we have a 5, let's use variable. Let's use x squared divided by x squared, which is I have x times x numerator, denominator I have x times x. So let's cancel. This one cancel, this one cancel. So I have a numerator, there's a 1, denominator, there's a 1, it's a 1, right? Now let's derive some formula. So if we use 2, then we have a to the nth power minus nth power, which is a to the 0. So a to the 0, this is, so let's rewrite one more time. We found out that a over a to the nth power divided by a to the nth power is indeed, if I use a power rule, a to the n minus n, which is a to the 0. But we all know from the very beginning what's the answer equal to. This is 1, because it's coming from, where is it coming from? It's coming from same thing over same thing right over here. So, in short sense, so let's summarize. In other words, if you have a to the 0 power is simply 1. So from now on, anything, let's write better. Anything, anything, anything to the 0 power, anything to the power is equal to 1. So this 0 is not really a 0. This 0 means it's coming from same thing, same thing, same thing over same thing. This 0 means it's not nothing. The exponent 0 means it means actually something. This means it's actually coming from same thing over same thing. So that's what we did pretty much last time. And today we are going to do number 4 right over here. Let me write. Number 4 is if you have a to the nth power and raised to the m, then it become a to the n times m. So for example, let's write the example over here. So if I have 2 cube parentheses 2 to the quantity 2 cube is everything is raised by second power, then we are going to multiply those two exponents. It will become 2 to the 2 times 3, which is 2 to the 6th power. The reason is this. The reason is if you have a 2 cube raised to the second power means I have another 2 cube multiply. So now this one is number 1 exponent rule. When you have a same base, what do we do with the exponent? We add the exponent, 3 plus 3, which is 2 to the 6th power. Or from the very beginning, just multiply. We'll have same answer. We have a same answer regardless of what you do. However, it is actually easier to remember one little thing. So let me write here is that parentheses, when you have a parentheses and exponent here, and exponent here, then you multiply. So there's some number in the base, right? You multiply. This is a scenario. All right. Moving on to the last one. So last one is maybe a tricky. It's about negative exponent. So if you have a to the negative m, this means 1 over a to the m. Or if you have a 1 over a to the negative m, that means a to the m over 1. Did you guys notice something? I want you to see this one. If you have a negative exponent, what happened? What's going to happen is it's going to go denominator. This one it goes to go numerator. So in order for you to visualize, let me write little thing. If you have nothing, you put 1 over, right? Remember that? So what does negative exponent do is it flips in a way. It's like flip. If it's a numerator, become a denominator and drop the exponent. If it was a denominator, it goes to the numerator and drop the exponent. So for example, let's do y first. So this is actually coming from the number 2. So we are going to use number 2 to find out y. So if you use number 2 of exponent rule, right? Let's use number 2. So for example, if we have let's do this one. For 5 to the second power divide by 5 to the 7th power. Do you guys remember we just did When we have a same base and divide it, then we subtract, but top minus bottom, 2 minus 7, which is 5 to the 2 minus 7 is negative 5, right? So let's see what that means. In order for us to visualize, let's open 5 square. 5 square means 5 times 5. And 5 to the 7 means I have a 1, 2, 3, 4, 5, 6. Let's write over here 7. And we can cancel. Same thing over same thing. This is this one, and this one cancel. This one and this one cancel. So I have a 1, 2, 3, 4, 5. I have a 5 to the 5th power, and numerator there's a 1. We start from here. We start from this one, though in the middle, 5 squared over 5 to the 7th power, and we found out we have a two answer. One is right over here, 5 to the negative 5. The other one is 1 over 5 to the 5th power. Since logically speaking they're both correct, therefore they better be they equal to each other. In other words, 1 over 5 to the 5th power better be equal to 5 to the negative 5th power. But let me write, important, negative exponent, exponent means, M-E-A-N-S means flip or reciprocal. But don't forget, when you flip, you must, okay, that means negative exponent. You must drop the negative sign. All right, there are 5 power rules that I can remember. And if you are able to understand these 5, then you'll be fine. And next one, we are going to use these power rules to solve some examples. All right, thank you for watching and see you next time.